Lesson 5.12. Melissa's doctor tells her that instead of taking 3 amoxicillin pills per day, she needs to take only 2 pills. When there is 1.5 grams of amoxicillin in 3 pills, how much amoxicillin is there in 2 pills? Okay, this is pretty easy. Well, you can't change the total amount of it, right? Because so I guess the pill gets a little larger, right? Because instead of taking 3 pills, she has to get all she has to get is just 2 pills, but still the amount is the same. So how do we get that? This is not really a hard problem. It is still true that 1/4 of amoxicillin will not be in her body the next day. Okay, so only 3/4 will remain, and 1/4 will go away. By doing the human activities, right? Will get out of the body, right? So how does the change in Melissa's prescription affect the recursively defined function shown below, which you use in example 1? So this is the recursive definition, right? So it's 0. You start from 0. D stands for the day, and A of D minus 1 means whatever that comes out from here. So it started out with, if you get the D's and A of D. If it's 0, it's 0, right? If D is greater than 0, for example, if it's 1, then you take that and add 1.5 and then subtract 1/4 of the previous one, right? So day 1 will be, so here this is 0, right? Because that's this one. And 0 plus 1.5 minus 1/4 of that, which is 0, that's that. So that's 1.5, right? 1.5. And the second day, you'll have the previous one, which in this case, we try to find this one. So we look at the previous one, which is 1.5, add 1.5, and then subtract 1/4 of previous one, which is this one. Okay? So A of D minus 1 is just the previous one. If you want to find this one, you look at this one. If you want to find out this one, then you look at this one, right? So that's what A of D minus 1. This looks complicated, but it's not really a problem. So suppose Melissa take 2 pills of amoxicillin per day. Find the amount of amoxicillin in her body after 1 week to the nearest milligram. She starts without any amoxicillin in her body. So you got to go up to 7 because you're talking about, a week after, right? So just extend this table and see what you get for the output. If it output of 7, right? The next problem. Each weekday, Cheng travels on the Metro rail system, making the round trip from Greenbelt to Metro Center. The daily fare is $2.85 each way. Cheng purchases $100 fare card to pay the $2.85 fare for each ride. Make a table that shows the amount of money Cheng has left on the fare card after n days. Show the values of n from 0 to 5. Oh, this is pretty easy. Okay, so you got n, you got what? What should we say? F of n, maybe? Okay, and then it says 0, 1, 2, 3, 4, 5, and these are, n stands for the days. And then you have to write, the output will be the amount of money that is left, right? So not the amount of money he spends, right? So you got to subtract whatever the money from 100. So if it's 0 day, how much money still there on the card? Obviously it's 100, right? And then the next day, he uses $2.85 times 2 because it's the round trip. If you don't use the one trip, he's not getting back. Maybe he got the ride from friends, but assume he has no friends, right? So keep doing that and find that out. B, describe the recursive defined function for the situation using words. So just using words, right? So find the pattern of output, previous output. What's the pattern from here to here? What's the pattern from here to here, right? Use words. And write the recursive rule, part C, define function b of n. Okay, so now it's b of n, all right? So this is b of n. All right, the amount of money Cheng has left on his fare card after n workdays. So write it out as a function, recursively defined function. Is this function linear? Is it exponential? That means, is it go up by constantly, or is it go down constantly? If it goes up or goes down constantly, it is linear. Is it exponential? So that means, does it go up constantly by multiplying some numbers, or does it go down constantly by multiplying numbers? So the difference between linear and exponential is, if it goes up or down constantly by addition, adding some numbers, positive or negative, that's linear. If it goes up constantly, goes up or down constantly by multiplying some numbers, that's exponential, right? E, use the function to find how many days Cheng can ride metro to and from work before he needs to add money to the fare card. All right, find that out. Once you get the recursive definition, or you can just keep going on. Well, I'm assuming that you are spending more than $5, right? So it should be less than 20, right? Because if you spend $5 and if you per day, and if you spend 20 days, that will be 100. So extend that table, probably, I don't know, 19, 18, something like that, right? All right, the last problem, I hope. Number 7, write about it. In example 2, which asks for the 100th output, the recursively defined function. So this example 2 means lesson 5.12, right? So we did that in class. Tells you to take the previous output and subtract an output before the previous output. What did you say? Tells you to take the previous output, take that, and then subtract the output before the previous output. The function gives the values 5 and 8 as the first and the second output. Explain why this function definition matches the description above. All right, so here's the description. So I think it's actually describing it's a description behind, I think. That doesn't make sense to me. Okay, so why this function define matches function definition matches that, right? The expression f of s of n minus 1 represent the previous output. What does the expression s of n minus 2 represent? So if it's 1 before, then if this is 1 before, this is what? You got 2 here, so it's 2 before, right? Okay, so let's take a look at next problem. Find 374th output. Good luck. Again, problem like this, you got to be really smart. Don't work hard, work smart, right? You don't want to have the tables up to 374. That's not the point. Problem number 9 in function s. Oh, if you need if you need to look at this, then go to the websites. You should have your account set up for online textbook if you don't have one with you. All right. The next one is in function s. The output repeats with a period of 6. Suppose the first output is y, the second output is z, and the third output is z minus y. Using algebra, find the sequence of the first 6 outputs. Okay, in function s. All right, let's look at this one. The period is the length of the repeating sequence, the sequence 7, 8, 9, 7, 8, 9, has a period of 3 because you have 3 items before you go back to the 7, right? Or 8. You know, you have 8, 9, 7, and then go back 8, right? So the period of 8. So the function s, the outputs, blah blah blah. Okay, period of 6. That means you have 6 numbers before you go back to the first numbers, right? Find the sequence of the first. Okay, find the sequence. Yeah. Okay, it's not that bad. So if it goes 5, that's a 5, 8, and this says subtract 1 before minus 2 before. 1 before was 8, 2 before was 5, subtract it, it's 3, and then you do it. 1 before, 1, so in order to find the next one you go 5, 1 before minus 2 before, and then in order to, so that you can find this one. In order to find this one, you go this minus this, right? What does using variables find the sequence of the first 6 output tells you? Okay, it's not that bad. Well, good luck.